Hello. Hello. Is it audible, please? Sir. Sir. Okay. Principal sir. Principal sir. Sir, Arjun Raj, sir. Is it audible? Kindly.
Yes, sir.
Yeah, yes. Sir, Arjun Raj, sir. Kindly wait for few minutes. Our principal will join.
Okay, sir.
Okay, okay. Sir. Sir, principal, sir, shall we start, sir? Sir, principal, sir.
Sir, guest untaangala?
Yes, sir. Yes, sir. Shall we start, sir?
Yes, we can start.
A day with getting new things and bearing knowledge with newly invented technologies. We keep moving forward for developing the ideas and for the contraption to build the unique machinery. Good morning to one and all present here. Our honor, Theni Melapate Hindu Nadarakal Uravin Muri Management well-acclaimed chief guests and secretaries, the principals, respected faculties, of course, our energetic students. We all are joined here for one-day webinar on hydrogen fuel cells for electric vehicle.
The capacity to learn is a gift. The ability to learn is a skill. The willingness to learn is a choice. Now I invite Mr. M. Mayugulu Esulakaram, third year, Department of Mechanical Engineering, to deliver the welcome address.
First, I would like to thank for giving this opportunity. I would like to welcome our team HNE management and our beloved principal, the secretaries and joint secretaries, and our vice principal, and our beloved head of the department, and all the faculties and coordinators, IIPC coordinators, for making the webinar possible, and our beloved students who are joined here for the webinar. I welcome you all for the one-day webinar. Thank you.
If your action inspires others to dream more, learn more, become more, you are the leader. Now let us such a leader, Dr. C. Madhalesundam sir, Principal of NSCET, to finish us again. Sir, please, sir.
Good afternoon. So I'm very happy to welcome Mr. P. Arjun Raj, the Director of Value and Tech Private Limited, Hosur, on behalf of the Department Industry Institute Partnership Cell of our Nada Saraswati College of Engineering and Technology and our management. Actually, that biofuels, the regular fossil fuels are getting exhausted in our world. It is getting exhausted. We need to find the alternative solution always. So a lot of alternative solutions are coming up in the upcoming era. So it's a one this particular topic, hydrogen fuel cells for electrical vehicles. It's a recent topic actually. But I request the students to get interacted with Arjun Raj sir, and I think he is working in that hydrogen fuel cells. And I'm having few questions, sir, actually. So what is the difference between the regular electrical vehicle and hydrogen fuel electrical vehicle? What is the efficiency? What is the efficiency? What is the cost? I'm having a lot of questions in my mind. Actually, see, while your presentation, I think you will give all the answers, I think. What is the raw material we are using? Whether it is implemented in a country like India? Is it possible to implement in countries like India? I think China, they produced the hydrogen vehicle, I think. So, what kind of research is going on in this particular area? So, I need answer for all this question actually. Students, I request the students to, you will get a lot of research-oriented topics, I think, students actually. Still, it is in process. Still, it is in developing area. It is a developing area in mechanical and electrical side. So you will get a lot of answers. It's a wonderful topic. I personally thank Dr. Sibagandhan sir. Continuously, he is arranging a lot of, he's bringing a lot of resource persons for arranging a lot of webinar, and he's picking interesting topics through this and Industry Institute Partnership Cell. And I personally thank Mr. Arjun Raj sir, Director, Value and Tech Private Limited, for his, he's ready to spend his valuable time with our students. So I thank you on behalf of the management. I thank sir. Thank you, Arjun Raj sir. So students, I request kindly be patient and listen. This another 1 hour. You will get some input. At least try to get some input from the guest. Okay, if possible, note down the questions, and end of sir's presentation, he'll give an answer for your questions. Okay. So thank you, sir. Thank you, sir Arjun Raj sir. Thank you.
Thank you, sir.
Thank you.
Thank you.
Thank you for your continued speech, sir.
Now it's time to chief guest address. Our chief guest P. Arun Raj sir, Director, Value and Tech Private Limited, Education Committee Member, Miles Value Foundation, USA. P.S. Arjun Raj sir completed BE Mechanical Engineering and Specialization Master of Engineering in Automobile from Anna University, Chennai. He is currently pursuing his PhD in B.S. Abdul Rahman Crescent Institute of Science and Technology in Department of Automobile Engineering. He has published 10 research papers in international journals, presented 11 research papers in international conferences and 10 research papers in national conferences. P. Arunraj sir have worked in BEML Limited as an engineer in service and validation department. Worked in Mahindra and Mahindra Limited in engines and R&D. Worked in PSA Group Motors in powertrain research and development department. Now I would like to hand over the session to P. Arunraj sir. Please, sir.
Hello all, I hope my screen is visible.
The screen is visible, sir. You can start, sir. The screen is visible. The audio is okay. You can start.
Yes, thanks a lot for an opportunity. Thanks Management Committee of Nara Saraswati College of Engineering and Technology for giving me an opportunity, and thanks the organizer as well. So my topic is hydrogen fuel cells for electric vehicle. The agenda of the presentation is it includes the introduction to hydrogen, introduction to fuel cells, and how the fuel cell is going to work. Okay, I'm going to cover working principles of the fuel cells, and then the schematic of the fuel cell electric vehicle. And then I'm also going to cover some of the features with respect to the design factors that have been involved for designing of the fuel cell electric vehicle. And finally, I'm going to conclude with some of the applications where this hydrogen fuel cell is being used in India and across the globe. So these are all the topics that I'm going to cover today, and most of the topics is also going to answer some of the questions which has been asked during the introduction session. So let us talk about the various types of fuels that are available in order to reduce emissions. So the conventional petrol and diesel, when it has been blended with biodiesel and petrol, when it has been combined with ethanol or methanol, so you have the option of reducing the emission. And as you know that you have a lot of emissions like carbon monoxide, hydrocarbon, unburned hydrocarbon, NOx. So in order to reduce the emissions, you need to have the petrol, which can be of clean and pure. And even you can also go for some biodiesel options where that will help you to reduce the emissions. And the other options that are available in the market to reduce the emissions include LPG, CNG, and the last two is the very recent technology which has been followed in India, where we are going with the electric battery vehicle and also the electric hybrid vehicle. And the last option is the electric battery and fuel cell vehicle, which we are going to cover today. And this is the graph where the x-axis is showing the years starting from 1990 to 2020, beyond 2020 as well. And these are all the y-axis involves the technology that are available, starting from the advanced IC engine, and then we go with the hybrid technology in order to reduce the COH in NOx. And you can see from the year 2005, the hydrogen fuel cells, the demand is also getting increased, and the usage is also getting increased in order to reduce the carbon footprint, at the same time the emissions. So this is the graph showing the carbon dioxide emissions in terms of kilogram per 1,000 kilometers. So when you're running the vehicle for 1,000 kilometers, you can see uh, the changes with respect to the CO2 emissions. You can see the number 6, which is nothing but the fuel cell car, which is using the hydrogen from the natural gas, which has been made out at large refineries. And even the number 5, you can see the fuel cells which is using the hydrogen, which has been distributed from the urban retail outlets. You can see the 5 and 6 is having the less CO2 emissions in terms of kilograms when it is running, or when you are running the vehicle for 1,000 kilometer. You can find the decrease in the CO2 emission is very less when comparing to the IC engine, where you have 250 kg uh, uh, in terms of the emission point of view when you're running the vehicle for 1,000 kilometer. And similarly, when you're running even with respect to the gasoline, fuel cell car with the gasoline and methanol, also you have a high amount of uh, emission. So the best way is to go with the hydrogen fuel cell, where you can reduce the carbon dioxide emission and carbon footprint as well. These are some of the advantages and limitations of the hydrogen that you have when you're using this as an alternate fuel. It does not generate CO2 when burnt. That is what it was been very crystal clear in the previous slide. And these hydrogen fuel cells are very efficient. At the same time, they also have some limitations. You have only few filling stations to sell hydrogen. Okay, almost 100 times lesser in terms of the stations, yeah, when compared to the petrol and gasoline. This is one of the limitation. And the other limitation involves the hydrogen must be compressed, and it should be liquefied, and then it should be stored in a fuel tank. I'm going to show you some of the schematic diagram of a vehicle like Toyota Mirai and Mahindra vehicle, three-wheeler vehicle, where you're gonna see the tank, how they are going to place it in a vehicle. And it's again, it's not a easy job to design and then to integrate it, and then to fix it in the vehicle, because it needs a lot of iterations, and it also requires a lot of validation as well in order to prove the concept of the vehicle. And again, moreover, the safety aspects also comes into picture. And the other aspects with respect to the limitation point of view is that the atmospheric pollutions may also be generated during the production of hydrogen. So this is also one of the factors that we need to look up into. And the last disadvantage is that hydrogen fuel cells will not be working at a low temperature. And this limitation is being overcome in a vehicle called Toyota Mirai, where they even operate at minus 20 degrees Celsius. And they have used some better catalyst, which is nothing but a platinum plus catalyst. And but again, again, disadvantage is that the cost is going to be higher. The Toyota Mirai, which I was mentioning, it is going to cost around 60 lakhs, which is highly expensive, and it is not affordable for a normal income people. So the cost wise is the higher side. And again, let us talk about the advantage of the hydrogen with respect to the vehicle point of view. First, I will go with the point of charging time, where you need to have very less charging time, 3 to 5 minutes. Okay, it is normal to how you are filling the petrol or gasoline. So the time required to charge or to include the hydrogen, to fill the hydrogen into a vehicle is 3 to 5 minutes, like petrol and gasoline. Whereas when you're going for an electric vehicle, where you need to charge a vehicle for 6 to 8 hours, unlike fast charging, it can take almost 30 to 45 minutes, but still it has an advantage of short charging time. And this is one advantage. And the noise level is also going to be reduced, and this can be suitable for all types of vehicle. And the performance is also better with respect to the internal combustion engine. And you have going to have the greenhouse uh, emissions where it is going to be completely green, which means there is no emission going to be there, and it is going to have zero emissions, not even a 0.001. So it's going to have the zero emissions. And here, as I said in the last slide, you need to have the catalyst when you're going for a fuel cell vehicle. But when even you can also go for a hydrogen where that can be applied into an IC engine. It is also an options where many OEMs have used. But today, the topic what I'm going to give is with respect to the fuel cells. Uh, so that's why I'm not going to cover the hydrogen into the IC engine application. And there are some disadvantages which I was also telling in the previous slide. Some which includes other disadvantages includes the infrastructure is also the problem, and the high cost of a fuel cell. So this is going to be that is what the Toyota Mirai vehicle which I was telling is going to be 60 lakhs. That is because of the cell cost itself. And you also have the little convergence of the fuel and vehicle design options. And the last disadvantage is that the low vehicle availability. Let us talk about the hydrogen, how it is been circulated from the start to end when it comes for a transportation point of view. So normally the hydrogen is being manufactured or produced using the hydrocarbon reforming process or electrolysis process or using the direct solar process. So where the first process is to produce the hydrogen, and next the hydrogen is being distributed to the various places through pipelines or mobile applications. And after distribution, the hydrogen is being stored. The storage is being through a solid state process or cryo applications or liquid applications or through a pressure or by help of a gas. And after storing the hydrogen in a particular place, then you're going to consume the hydrogen. It can be IC engine or it can be the fuel cells. So as I told, even this can also be used in IC engine application, and it can also be used in a fuel cell application. So today our topic is going to be the fuel cell. So you have two type of application. One is the conventional power generation, another one is the fuel cell power generation. Where initially in the case of conventional power generation, first comes the fuel, and fuel is fed into the combustion or a steam generator, where it is going to have the turbine, then the electric power is being generated. But in the case of a fuel cell application, you have the fuel, hydrogen as a fuel, which has been an input to the fuel cell, and you are going to get an electric power. In the case of a fuel cell application, the combustion, there is no combustion is going to be involved here. So, when there is no combustion, obviously it also eliminates the pollution, and also it improves the electrical uh, efficiency, conversion efficiency basically. Let us talk about the fuel cell. What is a fuel cell? Um, so, hydrogen is an input. So this is the anode. This is the cathode. So here, hydrogen is given as an input to an anode, and the oxygen is given as an input to the cathode. And you have two type of reaction. One is the oxidation reaction takes place in the anode, and reduction process takes place in the cathode. I will show you the chemical reaction, how it is going to happen in the further slides. And finally, you are going to get the net reaction, redox reaction you called, oxidation plus reduction you called redox reaction, where He2 will combine with an oxygen to produce the water. Okay, and here during the anode, when the hydrogen is entering, it splits into hydrogen and electrons, and only the hydrogen ions will pass to the. There will be a central electrode in between the anode and cathode called PEM, which is nothing but electrolyte membrane, and it will not allow the ions to pass into the PEM, and the electrons which will go to the electric system, which is generating the electric power, and that is being fed as an input to generate your motor for your application. Okay, so I will tell those things in the further slides. So let us talk about the introduction or the basics of fuel cell. A fuel cell combines with fuel, which is nothing but hydrogen, what we are going to see, and it is going to it's basically electrochemical process to produce electricity. Energy can neither be created nor be destroyed, but it can be transformed from one form of energy to another form of energy. That's what happens in ICE engine also. You have various forms of energy. Finally, you convert into a mechanical energy there. But here, the energy, chemical energy, is again transformed into an electrical energy in the case of the fuels. So, whatever the concept here, you need to understand the law of conservation of energy principle. And this fuel cell is also more efficient than an IC engine. It's almost 2 to 3 times. And you have the fuel cell stack, which is nothing but the combination of different fuel cells. Okay, it can be 100 fuel cells. So fuel cell is, it's not a single fuel cells, but again, it has a lot of small stacks. Okay, maybe 100 stacks or 50 stacks, depending upon the power output. You need to have more fuel stacks, and it is not going to have any moving parts, and finally, it is going to have the zero emissions as well. And you have a lot of various types of fuel cells which are available. So what I was telling is an electrolyte membrane. Here I was telling you during the introduction. So which is nothing but the polymer electrolyte membrane. And in addition to this, you also have various fuel cell types like alkaline fuel cells, phosphoric acid fuel cells, molten carbonate fuel cells, solid oxide fuel cells, and each electrolyte is going to have different pros and cons. So you can see the operating temperature also. Okay, when it comes for PEM, polymer electrolyte membrane fuel cells, it operates between 50 to 100 degrees Celsius, whereas alkaline it operates 90 to 100, PAFC 150 to 200, and molten carbonate it operates between 600 to 700, and the solid oxide FC which operates between 700 to 1000 degrees Celsius. So it's typically, as I said, PEM is the mostly used across the globe due to its operating temperature, and also based on the size as well. The size is also compatible. You can see the typical stack size is between 1 kilowatt to 100 kilowatt, which is less when compared to the other fuel cells. Even in terms of weight, also it gets reduced. And the efficiency, as far as the efficiency is concerned, still it is in par with the other type of fuel cells. Almost 60% we get with respect to the transportation point of view, and when you're using this for a test stationary purpose, still you can get 35%, which is still higher than the diesel application or the petrol application. And these are some of the applications where this can be used, like transportation, specialty vehicles, and portable power, backup power, distributed generation. Whereas the other application like alkaline fuel cells, it can be used for a military or space application, where the temperature is slightly higher, and again the capacity is also going to be higher. And the PAFC it can be used for a distributed generation application, and the molten carbonate can also be used for electric utility, and SOFC can be used for auxiliary power or electric utility or a distributed generation. And there are some challenges, at the same time some good advantages also you have. Let us talk about the PEM, where this solid electrolyte it reduces the corrosion, and also it is having a good electrolyte management problems, and this can also be used for a low temperature application, and it also helps for a quick startup. When I say quick startup, especially when the vehicle is running in a cold application, like and the vehicle is running in Europe application where you have minus 40 degree or minus 20 degree. Still, this type of fuel cells can be used there to avoid the startup issue in the cold condition. And the disadvantage here is it needs to have expensive catalyst. That's what the platinum, what I was telling initially. That is again going to be cost, and that is where it will also lead to the overall weight, overall cost increase of the vehicle as well, because of the usage of the uh, high amount of platinum catalyst. And one more disadvantage is that it's going to have the low temperature waste heat. And in addition to this PM, there are AFC, PAFC, MCFC, and SOFC, where it's good for other application apart from the transportation point of view. So I'm not going to cover all these things. So let us concentrate on to the PM at this point of time. So let us go. Why we need to have the hydrogen in fuel cells? Because it's going to be completely efficient, and it also going to be used to domestic fuels where the hydrogen can be used, can be manufactured with the help of those applications. And as far as the efficiency point of view is concerned, I told can get 60%, whereas in the case of IC engine you can get only 20 to 30%. And it is going to be convenient, and again it is going to be a completely noiseless process. Even the vehicle is also going to be noiseless, and it's going to have zero emission as well, and it's going to be highly versatile at the same time. It can be easily scalable as well. Let us go to the multiple uses of hydrogen, and as I said, this hydrogen can also be used in other aspects in addition to the transportation application as well. So the one application what we are going to talk to today is onto the fuel cell vehicles, which includes other mobile applications like mobile application is nothing but a mobility application. What you call it can be for any automotive applications, like can be buses or trucks or forklift, etc. And this hydrogen can also be used for an energy storage applications, where that can consist of a power cutting and establishing the grid application. And the stationary fuel cells also you have, where this can be used with respect to the cell phone towers or data centers or even hospitals and supermarkets as well, for generating even this can also generate electricity, where the stationary fuel cells can be used there. And this also used for petroleum refining process, where you got largest use of hydrogen which have been manufactured with the help of the refining process. And the last usage of hydrogen is the chemical factory or chemical field, basically, where the hydrogen is the second largest usage for the chemical applications that is being manufactured today. Let us talk how a fuel cell works, basically. This is the hydrogen which is an input, and this hydrogen is manufactured using the electrolysis process or deformation gases process or hydrated canisters or compressed cylinders, and hydrogen from the tank enters here. This is what I told you as a PEM, which is nothing but a proton exchange membrane. And you have the two type of catalyst. One is anode catalyst, and another one is a cathode catalyst. And catalyst is also I told you we are going to use a platinum as a catalyst. Okay. And hydrogen is an input to the anode catalyst, and oxygen or an air, or oxygen from the air. So air contains oxygen plus the traces of the other rare gases as well. So, but 78% of comes from 78% comes in terms of oxygen from the air, and that is fed into the uh, inside of the cathode catalyst, and the output will be an H2O. And you have an electric circuit here, I will tell you how this is going to work in the next slide. We also have the blowers and oxygen cylinders, which is an input to the cathode catalyst basically. This is again the schematic of fuel cells. You can see the oxygen is entering into the cathode, and in the anode hydrogen enters in. Okay, hydrogen, and hydrogen is going to split up into H plus and ions. H2 plus two hydrogen plus two electrons. Okay, when I say electrons, these electrons will go. It will not enter into the PEM. It will not enter into PEM because only the proton enters here, and this electrons, the flow of electron is nothing but the current, and it goes to the electrical circuit and generates electricity, and that electric is going to the motor for your vehicle. And finally, you also get an water out and at the same time heat out as well. This is the cell reaction, where at the anode side we have the H2 when it splits up into 2H plus and 2E minus, which is nothing but the electrons. And in the cathode, oxygen is an input, and when this oxygen it reacts with 2H and 2E minus, it gives water. Okay, and finally the net reaction is going to be water plus, means water is going to be the final net reaction process, and water is highly emissionless. Okay, which means zero emission you're going to get when water is going to come out of your tailpipe. So you have the PM fuel cells where this layer is going to be the GDL, which is nothing but a gas diffusion layer, and this GDL is going to be there at both sides, one in the anode side at the same time at the cathode side, and you also have the two bipolar plate besides the gas diffusion layer, and this was the reaction that we have seen in the previous slide, where the hydrogen splits up into hydrogen plus electrons in the anode, and in turn in the cathode the oxygen is mixed up with the hydrogen, and then the same electrons which is coming out here, and it's going to give us some water. And this is the platinum is used as a catalyst, and as I said, the electrons is not going to enter into the PEM. Instead, uh, these electrons will take a external part where it goes to the load called electrical circuit load, and it generates electricity. And this fuel cell, this one fuel cell. So like this, you are going to have a different combination of the fuel cell, which is nothing but a fuel cell stack. So you can see first cell number 1, cell number 2, cell number 3. Like this, you will have n number of cells depending upon your requirements basically. Okay, and the cells are stacked in series like how you are using the dry cell batteries. So you have the voltage and then the current. So if you want to have the high output, you need to have the high voltage and then high current. So you can increase the current by increasing the layer of when you are increasing the size of it. When you're increasing the size of it, you're also going to increase the output. At the same time, each cell is going to have some specific amount of voltage. Okay, so higher the voltage, you also get a higher output. So in order to have the high output, this is one advantage where your application. And of PEMFC, which is nothing but proton electrolyte membrane fuel cell development. First one is going to be the cell. Okay, each cell is made into a stack. It can be the combination of 100 cells or 50 cells or 45 cells, whatever, depending upon the requirements. And then that is been as an input to the power pack, and that is fed into the system. Okay, so first you're going to have the cell which is getting into the manufacture. You're going to manufacture the cell individually, and you're going to stack it together, and you're going to use it for the power pack application, and that is fed into the electric into the vehicle. Basically, system is nothing but vehicle basically. Okay, so as I said, the fuel is an input and air is also an input to the fuel cell stack. Okay, and fuel is nothing but the hydrogen fuel, and the fuel gets processed and enters into the fuel cell stack, and the air is also entering. And you have the power electronics where it controlled the complete electronic aspects of the fuel cells, and the output is going to be the electrical output. And you also have a thermal output, because water plus heat is also comes out. And you also have the hot water storage, and which is nothing but a form of a thermal energy here. And our area of interest is going to be here, where the electrical output is going to come. So this is a schematic of a fuel cell electric vehicle, where the fuel cells and the battery are being operated in parallel, and they're coupled to an electric motor. This is an electric motor through a DC-DC converter or a DC-AC inverter. You see here, inverter is the one which converts the DC into an AC. Okay, when you're using AC motor, you cannot have the DC because the current which is or the electric current which is coming out of the fuel cells is going to be DC, and in order to convert the DC to AC, you need to have an inverter, and that can be used as an input to an electric motor. And you also the vehicle, what I was telling, the fuel cell electric vehicle operated by an hydrogen, it also having a regenerative braking application, where that will also help you to charge your battery as well. And this, see, when I say fuel cell electric vehicle, it's not just a fuel cell alone, even that is also having the battery as well. Okay, both the fuel cell and the battery are sized in order so that the total power is going to get increased. And hello, okay, just okay. So when you're going for the fuel cells and the battery, which it will also going to increase the total power. At the same time, this will also help you to increase the overall the power output of your vehicle as well. Okay, this is a schematic for a parallel and series hybrid of fuel cells vehicle. Basically, you have a fuel cell stack, and as I said, you need to have a converter. Based on that, you see, in the case of a series hybrid, which is where you have the small fuel cell and large battery bank, and this battery drives motor all the time, and this fuel cell operates continuously and keeps the battery charged, and the fuel cell is not being loaded here. You can see the structure here, where fuel cell stack into the DC-DC converter, then it goes to the battery, inverter, and motor. And this can here accelerated devices are there. In the case of parallel hybrid, where you have the large fuel cells and the small battery bank you have, and this is mostly used in the vehicle, because you need to have the application where it needs to have the high fuels, means large size of the fuel. That's what we have also seen here. Both are being connected in parallel. Okay, and this fuel cell drives the motor all the times, and it is going to follow the load. And this also have the battery, which provides the extra power when it is required. You can see the fuel cell stack where the electric current is coming, and you have the DC-DC converter, and this is converted to AC, and this is an input to a motor, and it goes to the wheel and transmission, and then to to the wheel. And you also have a supercapacitor or a battery for you to operate uh, in the case of both with respect to the regeneration mode at the same time. The excess power, if you have more power, okay, the extra power is also goes here, uh, which also helps you to. It's a general thing, like even you have the battery operated electric vehicle where you go for a lithium ion or a metal hydride battery. So this is also having the both combinations where you can use not only with respect to the fuel cells, when this can also be battery operated electric vehicle as well. This is also going to be hybrid as well. And this is the uh, schematic of a fuel cell plus battery. Hybrid is nothing but both. It can either operate fuel cells or it can be operating through battery. Suppose if there is a problem with respect to the hydrogen availability, then we can also go with the help of battery operated mode as well. Um, but again, however, in order to charge the battery, you need to have the, the power, which in turn uh, that comes through the fuel cells basically. And it is the fuel cell stack and goes to the DC-DC converter, and you have various DC bus application where it can be of DC-DC or DC-AC, and that goes to the motor and transmission and wheels. And in the case of here, you have various auxiliaries like compressor, anode pump, coolant pump, radiator fan, and you also have the controller. So in the case of motor, you have the anode pump where this pumps the hydrogen, and with respect to the electric onboard system, because the heat is the generator is going to be very high. That's what I was telling. You have two type of energy into it. One is electrical energy and one is thermal energy. When it comes for a thermal energy or a thermal heat or thermal waste, you need to have some coolant in order to cool the system, where the radiator also comes into picture, and you have a controller where it controls the voltage or the current, and then uh, and the complete structure where it also have the balance, basically a balance between the motor and then the battery for you to operate the vehicle. This fuel cell electric vehicle can also be used for a truck application. I will where many OEMs had also been used this one for a truck application as well. Where you have a DC-DC converter. This is nothing but a DC bus bar, DC bar you call, and it goes to the inverter, and then it goes for electric motor and to the wheels, and it has lot of inputs from the pulse width modulation, or you call your power electronics here. Um, Depending upon the load inputs, you also get the output of the particular load, and depending, because you need to have the high load for a truck application, based on because the load carrying capacity is going to be higher. So that's the reason it's going to have the 20 kilowatt here. And here you're also going to use 600 to 650 volt volts battery. And this, as I was telling, this fuel cell, one fuel cell is nothing but one single fuel cell unit. And when it have multiple units, it's nothing but a fuel cell stack. And you also have the specification for the fuel cell stack, where you need to have a high number of cells which has been packed together, and higher the voltage, higher the current you need to have more number of fuel cell unit basically. And in order to have the FCEV accessory load, you have a lot of accessories load in a vehicle, for which not just a 12 volt battery alone is sufficient. You also need to have the high voltage battery, and you also need to have the ultra capacitor in addition to the fuel cell, because ultra capacitor will help you to take to store the energy, or to take the energy whenever it's required, or to supply energy whenever it's required to operate for some of the accessory loads in your vehicle. This is schematic of a electric powertrain for your FCEV. FCEV stands for fuel cell electric vehicle. Okay, so you can see here this is a fuel cell system. It can be of either a single way or a two-way. It can be one-way electrical system, or two-way electrical system, or two-way mechanical system. See, the fuel cell system it goes in a single direction to operate the vehicle accessories, and you have two type of thing where you have DC AC converter. It converts DC to AC. AC goes to the electric motor, and as I said, the supercapacitor has been used in order to increase the power occurrence and also for the better energy storage as well. And this supercapacitor are being used for increasing the power density of the system as well because of their low terminal resistance. And the presence of the energy storage system itself is not enough for the vehicle power density in order to reach the expected power. And this power electronics is also helpful for you to help for interface between the power demand and at the same time the energy supply as well. So whenever FCEV in order to drive your motor. Let us talk about some of the design factors that are fuel cell stack. And you also have, and it's a vehicle current. It is a combination of fuel cell current and the battery current. And this fuel cell could run continuously for 3 hours, which you can also sell. It can also guarantee times you can reduce, which means instead of 860 million gallons uh, consuming this much amount of fuel per year, you can consume only 688 million gallons. So that this also helps for you to increase the to reduce basically the fuel consumption. And this is the layout of a hydrogen fuel cell, where you have the fuel tank where the hydrogen is being stored. And you have a battery pack, you have a fuel cell stack, combination of different fuel cells, and you have the traction motor, electric motor, you have a DC-DC converter, you have the cooling system, thermocooling system, you have the battery, and you have the transmission application, you also have the power electronic controller. These are some of the fuel cell electric vehicle passenger car in India. Not only in India, it's across the globe. In India, you have Toyota Mirai. You also have the Hyundai Nexo, and across the globe, you have Hyundai iX35, Honda Clarity fuel cells, and Mercedes-Benz GLC fuel cell. And this is the Honda FCX Clarity. Basically, this is also a hydrogen fuel electric cell. Sorry, it is not a hydrogen. It's basically a hydrogen stored IC engine. This has been operated with the help of IC engine. But they also have a dual application. That's what they have both applications where they go with engine application, at the same time they also have the fuel cell application. Just a second. Okay, so you see here, let us go to the step-by-step application where the hydrogen is been stored into the hydrogen tank, and the second one is you have the fuel cell stack which generates electricity, and the third one is you have the lithium-ion battery which stores electricity, and the fourth one is the PTV, which is nothing but the power drive unit which governs the electrical flow, and the fifth one is that it propels the electric vehicle. Okay, and this is with respect to the fuel cell electric vehicle, and you also have the range where it goes up to 280 miles basically, and the hydrogen storage is at the rate of 4.1 kg at 5000 psi. And this fuel cell electric vehicle is also been applicable for a bus application where the Mercedes-Benz is been using this fuel cell application for some of the Europe market, where almost 30 fuel cell buses are operating on the road across the different parts of the Europe country for the past 2 years. And you see, this is the bus which is nothing but manufactured by Toyota, It's a big bus. It's a big one having the low floor and the fuel cell hybrid bus, and it also helps to improve the air quality in urban areas as well. You can see the hydrogen fueling here. It's an input here, and we have the high pressure storage tank in the top, and we have the motor, you have the power control unit, you have the fuel cell stack. At the same time, you also have the applications having the 3 kilowatt or 5 kilowatt fuel cell application. You can see the fuel cell power conditioning unit. You have the storage tank. You have the this is the fuel cell, 3 kilowatt each, and you can see this is the vehicle basically called Mahindra three-wheeler application. And this is the specification of a Toyota Mirai FC EV, where, as I said, this cost is going to be almost close to 60 lakhs, and the width of the vehicle is going to be 1,815 mm, and the length is going to be 4890 mm, and the wheelbase is going to be 2780 mm, and the height of the vehicle is going to be 1535 mm. And this test has been done with the help of a new emission driving cycle, where the maximum speed of the vehicle is going to be 178 km per hour, and this is going to have the fuel stack, cell stack, which is going to be have a 3.1 kilowatt per hour as in volume power density. At the same time, the maximum output is going to be 114 kilowatt, and we have hydrogen two number of tanks in the vehicle is going to be 2, and nominal working pressure is going to be 700 bar, and you have the motor, which is going to have 113 kilowatt, and the maximum torque is going to be 335 newton meter. These are all the main components of a Toyota Mirai fuel cell electric vehicle. You have a fuel cell boost converter, which is highly compact and highly efficient, and this high capacity converter is been newly developed to boost the fuel cell stack voltage to 650 volts. As I said, when you have high voltage and high current, your output is going to be higher. When I say output, the output is nothing but this maximum output what you are. So in order to have this much 114 kilowatt, you need to have that much level of voltage and that much level of current. Okay, I told you the number of fuel cell stack. It also depends on the one fuel cell will have some amount of voltage. Okay, so when you add all the things in a stack, you will get the required amount of voltage and then the required amount of current in order to meet the required amount of output. And you have the power control unit, where it is the power control unit where this helps to optimize the fuel cell output at the same time to drive the vehicle using the battery charging application and even doing the discharging as well. You have also have the motor, and you have the high pressure hydrogen tank, where this has been sourced 100 bar, and you have the hydrogen vehicle in which you have a battery, where this is not a lithium ion, but this is going to be nickel metal hydride, which stores energy recovered from the deceleration, and also it assists the fuel cells stack output during the acceleration. And as I mentioned, this fuel cell stack is going to have the output as 114 kilowatt, having the volume power density as 3.1 kilowatt per liter. And this fuel cell is been used in two type of application with respect to the transportation. One is the propulsion application, another one is going to be the auxiliary power unit. In the case of auxiliary power unit, where you go with the truck application, luxury car, and even this can also be going with the partial fully replaced battery with 5 kilowatt plus capacity, and this can able to provide power independent of the rest of the powertrain, which is an alternative to an IC engine. Uh, and with respect to the propulsion point of application, where hydrogen can be used, and even this can also be used for a low application, where for example scooters, where having the range between 2 to 5 kilowatt plus, and also the cars, where it can go up to 50 plus kilowatt capacity, and even for the buses application, where it can go up to 150 kilowatt plus. And as I was mentioning that fuel cell can be going with a parallel or a series hybrid, where a parallel hybrid is a very good option for an automotive application. This can be used uh, there for as a point of propulsion point of view. So we have two type of fuel cell application. One can be used for the propulsion aspects, another for an auxiliary power unit. And these are some of the technological development which is happening in India with respect to the hydrogen point of view. So the title here is Hydrogen in Transportation Technology Development with respect to the Indian scenario. So we are talking about the PEM fuel cell, polymer electron membrane fuel cell. So these are all the organizations which they are doing, which are working like Tata, ISRO. They are doing the system integration using the bought out stacks. They are doing some simulation for a bus application basically, and Reva. So, and they also have the system integration using the bought out stacks. They also trying for a four-wheeler application or a van application basically. And you have the Birla Group, Bajaj, Mahindra, TVS, Mahindra, Reva. So they are also working together for this development of this PMFC. The Reva SS, Indian organization called ARCA. They had a very good facility for the fuel cell development and also the technology transfer. They also helping many three-wheeler and also the four-wheeler application to come into the market. And in addition to this PMFC, you also have the other fuel cells, as I was mentioning. You also have the alkaline fuel cells and PAFC fuel cells. This can be used for some of the defense application, and also even these alkaline fuel cells can also be used for some of the uh, uh, three-wheeler application where Bajaj is trying to use it. And you, as I was telling you that this hydrogen, apart from fuel cells, can also be used for some in combination with an IC engine, where many organizations, many universities is also partnering each other for the development of a two or three or four wheelers. It's not just a demo, but they are trying to bring to the market as well. And here, it's not the role of one engineer alone. The development of the fuel cell or fuel cell stack. It involves various engineers involved into it to develop the fuel cells. So you see here, you need to have the proper material engineer, and you also need to have the proper electrochemist. Where the here you have the catalyst, as I was telling, platinum or whatever the catalyst. It involves the chemical engineer there, and it's completely going to be the thermal management system where the thermal engineering is also important for you to work. And you also have the hydraulic engineer, and you have the mechanical engineer, you have the electric engineer. So all this cross-functional department is going to work together in order to develop the fuel cell and also for you to be a more successful one. So thanks for an opportunity, and you can obviously mail me at p.arjunraj@gmail.com, and you can do contact me any point of time. Thanks a lot, and thanks once again for this opportunity. I look forward for some of your queries.
Thank you, sir. Thank you very much for your excellent delivery. Now we will go for query session.
சார் இப்போ வந்து ஹைட்ராலஜி யூஸ் பண்ணோம்னா எஃபிஷியன்சியும் மைலேஜ் வந்து எல்லாமே இன்க்ரீஸ் ஆகும்னு சொன்னீங்களா?
So if I understand your question, when you're going for applications where I was telling you with respect to the range point, you're asking about this range, right? Where when you're going with a battery with a fuel consumption, you get a high amount of range. So this is what you're asking, right?
How can it is possible, sir?
Okay. See, when you're charging your battery, you see here, when you're charging your battery, you would have heard the charging time and then the discharging time. And when you say discharging time, which is nothing but the range, how much you are going to cover the vehicle from 100 percentage charging to say near to 0 percentage of it. Okay, so that is nothing but a range. Okay, so when you're going for a fuel cell along with a battery, uh, you have a current where you are going to have a combination of fuel cell plus battery, where you can see the power output is also going to be higher, which means you can see the orange color. Okay, so here you have the high power output where the combination of the battery along with the fuel cell will help you to increase the range. At the same time, whatever the mileage what you call here, so in terms of miles or in terms of kilometers, is going to be much more higher when comparing to that of pure battery. Because in battery, if you are considering only battery, you can see only the green color alone. Okay, but in addition to the green, you also have the blue color. Okay, which is nothing but the fuel cell current. Okay, current is nothing but you can convert the voltage into current, which is nothing but the power output. Okay, so this is basically a power output which you're going to this is the reason where the mileage is on the higher side for the fuel cell plus battery operated electric vehicle.
அப்போ ஆல்ரெடி இருந்த வெஹிக்கிளே வந்து யூஸ் பண்ண முடியாதா சார் இது?
See, if you're having only the electric vehicle currently, so you are asking me whether the hydrogen can be used as an alternative for that, right? Whether my question is correct to you or not? You are asking
Right.
me whether can we use the hydrogen fuel cell as as an additional accessories for unexisting battery electric vehicle, right?
தேங்க்யூ சார்.
Yes, it is not possible because what happens is, as I said, you need to have the hydrogen tank, you need to have the fuel cell, because that's where the integration comes into picture. But in our, you cannot you cannot do in that way, but you need to completely design newly because it is going to have a space for you to have the you see here what the question for what you're asking is, if you have the battery, okay, can the same vehicle can be used with the help of by adding the hydrogen fuel tank. So but it is not possible because you see here, uh, the two wheeler, the four wheeler, what you can have, even the Tata vehicle, Nexon, whatever you take, you cannot directly add the hydrogen tank into it because this will weight more. When you have high weight, what happens? It will also affect the stability of your vehicle, and you also need to have that much space to accommodate this fuel cell hydrogen tank as well. So this is a bit complicated. You cannot directly go for a conversion from a battery electric vehicle to fuel cell electric vehicle because of its space application, at the same time the stability issue. Um,
தேங்க்யூ சார்.
Hope I have answered your question, right?
எஸ் சார்.
The next question, can I proceed?
Yes.
What is the pollution rate for the production of hydrogen fuel cells, sir, when compared to other fuels?
Okay. So that's what I will just tell in two ways. Okay, one with respect to the electric vehicle, another one with respect to hydrogen. Okay, so the electricity has been produced in various ways. One is coming from the coal. The pollution of the coal is going to be higher than the vehicle which you're going to run. Okay, and you can also produce electricity through solar means and nuclear. There are other various ways as well where you can go uh, for a less pollution basically. Okay, but unlike this, what happens is the pollution coming manufacturing of the hydrogen, because hydrogen have to compress and you have various processes I was mentioning. It can be reformed, it needs to be refined, and the pollution is extremely high for the production of the hydrogen. Okay, in terms of numbers, I am not pretty sure, but that is also higher compared. It's similar, but it's slightly more than what you have from the coming out from the coal, basically. Um, this is one disadvantage. That's what I was telling in the first slide.
Thank you, sir. I understood.
In terms of number, I'm not sure, but again, this is going to be challenging again in terms of pollution point of view. Even you can see in some of the things where the smokes comes in a very large scale uh, from the from the from the hydrogen manufacturing company. Almost it again, they're also using some of the blend in the exhaust where they're trying to reduce some of the NOx. But again, with respect to the vehicle point of view, it is less. But making hydrogen, it is also, it's not, it's going to pollute the atmosphere again. But the level, it's very good question, but I don't have the correct percentage how much it's going to be on the higher side. In terms of that, I'm not sure.
Okay, sir. Thank you, sir. Is there any question from external participant, please? I request external participants.
Okay.
Is there any-
Sir, just maybe to answer the question of a pollution. Say, for example, if you're manufacturing, or if you're producing 1 gallon of hydrogen, then almost 9.1 kg of CO2 is being manufactured. So it's but again, this the amount I can give you one more comparison where that you can correlate with the hydrogen and with the petrol and gasoline. What I was telling you is that you can see this comparison. What I was telling, the emission wise, when you're manufacturing, even this is with respect to the vehicle point of view, and even if you are manufacturing the 100 gallons or 1000 gallons of hydrogen versus petrol versus diesel, still uh, the emission is going to be lesser with respect to those application. In that way, I can correlate, but when it comes for the overall pollution, still it is on the higher side.
external participants, the feedback link will be sent to your registered email ID. By filling up your feedback form, you can get your certificate. Thank you. Thank you for your participation and patience. Thank you, sir. Now we will conclude the session. Yes, sir. Do you have any questions, sir? Doctor?
சார் வணக்கம் சார், கேக்குதுங்களா?
Yes, sir.
Sir, my question to the expert Arjun Raj sir. Sir, if you want to design a minimal setup for two-wheeler, whether we can use this hydrogen-based system, or whether we can use this fuel cell-based setup. If so, then what is the design capacity, sir?
Sir, can you repeat your question, sir? Because
Sir, I want to set up a two-wheeler using this hydrogen fuel. So what should be my design for a two-wheeler which can carry two persons at a time?
okay. We can have Okay. So for a two-wheeler application, it's the capacity is going to be very less, unlike in the case of what I was showing for a four-wheeler, where you need to have the big tanks, where two, three tanks you need to have. But again, in the case of two-wheeler, you can have a small tank, depending up. But again, you need to define how much is the capacity, how much should be the voltage, and so how much should be the current, how much should be the kilowatt. That's where the design comes into picture. So you need to first design. You need to look at into design aspects, and then you need to go for a application. But yes, it is definitely possible, and this is not the challenging aspects also for a two wheeler. But only problem here with respect to two wheeler here is as we have also have a battery electric vehicle for a two wheeler. But again, going for a hydrogen, it will also increase the weight of the vehicle. That's where the balancing, even the battery electric vehicle, what we have today, that itself is coming more weight, and adding additional to that, and stability of the vehicle is going to be a big problem. But still, many OEMs across globe have tried this option. But again, because of its overweight, they're restricting only to either hydrogen with IC engine application or only battery electric vehicle. But again, hydrogen to IC engine, still it is not an option for a two-wheeler application, but that has been an application for a four-wheeler. But because of the high weight, they are not going for the two-wheeler application. But still, it is a viable option.
Yes, sir. Understood. Sir.
But this can be used for a three-wheeler application because you have a good space also. You can keep the fuel tank. But the only problem is the. Yes, sir.
Sir, one more question, sir. Is it feasible to set up for a university campus? Whether we can have this power which can be utilized for a university? Is that kind of setup is possible?
Yes, for stationary application and for there we can try. Yes, we can use it. It is possible.
Thank you, sir. Thank you.
Thank you, sir. Thank you for your valuable answers and presentation. I think we will conclude our session now.
Small things are always worth more than the efforts take to do it. I would like
It is immense pleasure to deliver vote of thanks for this greatest occasion. First, I would like to thank the TMHNU management for providing this opportunity. Now, I would like to thank our NSCET secretaries and the joint secretary. Next, I would like to thank our principal sir and vice principal sir and